Most people hear the words high voltage and immediately think about danger. But behind every power plant, industrial facility, electrical substation, and manufacturing complex are highly trained professionals who make working with enormous amounts of electricity possible. High voltage electricians are responsible for installing, testing, maintaining, and repairing electrical equipment operating at voltages far beyond what most electricians ever encounter. Their work keeps factories running, hospitals supplied with reliable backup power, renewable energy systems connected to the grid, and entire industrial operations functioning safely every day. Although many people confuse this career with that of a power lineman, the two professions are very different. Linemen primarily build and repair overhead transmission and distribution lines outdoors, while high-voltage electricians specialize in the equipment that controls, transforms, and distributes electrical power inside substations, industrial plants, power generation facilities, and large commercial installations. Their workplace is filled with transformers, switchgear, circuit breakers, protective relays, bus bars, and sophisticated electrical systems that require both technical expertise and absolute precision. The journey usually begins with the same electrical fundamentals every electrician must learn. Future high-voltage electricians study electrical theory, safety procedures, blueprint reading, electrical codes, and industrial wiring before ever working around energized high-voltage equipment. Most enter the profession through an apprenticeship, trade school, or electrical contractor training program, where they spend years developing the skills needed for increasingly complex assignments. Safety becomes the foundation of everything they do. Before touching any energized system, apprentices learn lockout-tagout procedures, grounding methods, arc flash protection, confined space awareness, and the correct use of personal protective equipment. Every task follows carefully documented procedures because even a small mistake around high-voltage equipment can have catastrophic consequences. During the early months of training, apprentices rarely perform complex electrical work themselves. Instead, they observe experienced electricians, organize specialized tools, inspect equipment, assist with cable installations, and learn how every component inside a substation or industrial electrical room works together. Patience is essential because mastering high-voltage systems takes years rather than months. As confidence grows, apprentices begin performing routine inspections on transformers, disconnect switches, circuit breakers, and control cabinets under close supervision. They learn how to recognize overheating components, damaged insulation, loose electrical connections, and early warning signs that could eventually lead to equipment failure. Every inspection teaches them that preventing electrical failures is just as valuable as repairing them. They also become familiar with specialized testing equipment capable of measuring insulation resistance, continuity, voltage levels, and equipment condition without compromising safety. Unlike residential electricians, high-voltage electricians depend heavily on advanced diagnostic instruments to evaluate systems that cannot simply be switched off without affecting major industrial operations. Every reading must be interpreted correctly before any maintenance begins. Their workplace continues expanding beyond classrooms and workshops into real industrial environments. One day they may assist inside a modern electrical substation. The next they could be working at a manufacturing facility, renewable energy installation, refinery, or power generation plant. Every location introduces new equipment, new procedures, and new technical challenges. Throughout this stage, experienced electricians constantly reinforce one lesson above all others: confidence must never replace discipline. The best high-voltage electricians are not those who work the fastest, but those who consistently follow procedures, verify every measurement, and never take shortcuts around dangerous electrical systems. By the end of the apprenticeship's first stage, the new electrician has developed a solid understanding of industrial electrical equipment, safety protocols, and diagnostic testing. The responsibilities continue growing with every successful project, But the next level of the career introduces far more sophisticated systems, larger substations, higher voltages, and technical challenges that demand an entirely new level of expertise. As high-voltage electricians gain experience, their responsibilities expand far beyond routine inspections and basic maintenance. They begin working directly on the electrical systems that keep major industries, power plants, and critical infrastructure operating around the clock. Every assignment requires careful planning because the equipment they maintain often carries thousands, or even hundreds of thousands, of volts. At this level, precision becomes just as important as technical knowledge. Before any maintenance begins, every circuit must be properly isolated, verified, and grounded using strict safety procedures. Teams carefully follow lockout-tagout protocols, confirm the complete absence of voltage, and document every step before touching any energized equipment. One overlooked detail can place an entire crew at risk, which is why experienced high-voltage electricians develop a mindset built on discipline rather than speed. Much of their work now revolves around the massive equipment found inside electrical substations and industrial facilities. Power transformers become one of their primary responsibilities. These machines continuously step voltage levels up or down to allow electricity to travel efficiently across the grid before being safely distributed to factories, businesses, and communities. Inspecting cooling systems, replacing bushings, testing insulation, and analyzing transformer oil all become routine parts of the job. Circuit breakers operating at high voltage also require constant attention. Unlike the breakers found inside residential homes, these industrial units are capable of interrupting enormous fault currents within fractions of a second. High-voltage electricians inspect mechanical components, lubrication systems, contact wear, and operating mechanisms to ensure they will perform instantly whenever an electrical fault occurs. Protective relays introduce another level of technical complexity. These intelligent devices constantly monitor electrical systems and automatically isolate damaged equipment before failures spread throughout the network. Electricians learn how to configure, calibrate, and test these protection systems using specialized digital equipment that simulates electrical faults without placing the actual grid in danger. Diagnostic testing becomes one of the most valuable skills at this stage of the career. Using insulation resistance testers, micro-ohm meters, transformer turns ratio analyzers, primary and secondary injection equipment, thermal imaging cameras, and partial discharge detection instruments, high-voltage electricians can identify hidden problems long before they become expensive failures. Their ability to interpret test results often saves utility companies and industrial facilities millions of dollars by preventing unexpected shutdowns. Their work environment also becomes far more diverse. One week may involve maintaining substations supporting renewable energy farms. The next could involve servicing electrical infrastructure inside refineries, mining operations, steel mills, chemical plants, data centers, or large manufacturing facilities where uninterrupted electrical power is essential. Every industry presents unique equipment, operating procedures, and technical standards that require continuous learning throughout the career. Emergency response becomes another important responsibility. When transformers fail, substations experience equipment faults, or industrial facilities lose critical electrical systems, experienced high-voltage electricians are often called immediately, regardless of the hour. They work alongside engineers, operations personnel, and maintenance teams to diagnose problems quickly while ensuring every repair is completed without compromising safety. As their reputation grows, younger apprentices begin looking to them for guidance. Experienced electricians teach proper testing methods, explain complex protection systems, and demonstrate the disciplined approach required for working around high-energy electrical equipment. Employers reward this expertise with greater independence, higher salaries, and opportunities to participate in increasingly complex electrical projects. But the highest level of the profession extends beyond maintenance alone. It involves commissioning entirely new substations, supervising major infrastructure projects, and becoming one of the specialists trusted with some of the most sophisticated electrical systems powering the modern world. The highest level of a high-voltage electrician's career is reached only after years of experience, continuous training, and an unwavering commitment to safety. At this stage, these professionals are trusted with some of the most complex electrical systems in the world, where every decision can affect critical infrastructure serving thousands, or even millions, of people. Their work is no longer limited to maintenance. They become technical specialists responsible for commissioning new substations, upgrading aging electrical infrastructure, and ensuring that entire facilities are ready to operate safely before power is ever applied. Commissioning is one of the most demanding phases of any high-voltage project. Before a newly constructed substation, industrial plant, or power generation facility can begin operating, every transformer, circuit breaker, relay, protection panel, cable, and control system must undergo extensive testing. High-voltage electricians carefully verify wiring, inspect protection settings, perform insulation tests, analyze switching sequences, and simulate electrical faults to confirm that every component responds exactly as designed. There is no room for assumptions when energizing equipment capable of carrying hundreds of thousands of volts. Many experienced electricians eventually specialize in highly technical areas such as relay protection, transformer diagnostics, high-voltage cable testing, or predictive maintenance. These specialists become invaluable because they can identify hidden problems long before they lead to catastrophic failures. Using advanced technologies such as dissolved gas analysis, partial discharge monitoring, infrared thermography, and computerized diagnostic systems, they help utilities and industrial companies avoid costly outages while extending the lifespan of critical equipment. Leadership also becomes a central part of the profession. Senior high-voltage electricians organize maintenance schedules, coordinate contractors, supervise testing crews, and ensure every project follows strict engineering standards and safety regulations. They review technical documentation, approve switching procedures, and mentor younger electricians who are beginning the same career path they once followed. The electrical industry itself continues evolving rapidly. Renewable energy installations, battery storage facilities, modern data centers, and increasingly intelligent electrical grids require professionals capable of working with both traditional power systems and sophisticated digital technologies. Experienced high-voltage electricians often participate in integrating solar farms, wind generation facilities, and smart substations into existing electrical networks, helping modernize the infrastructure that powers entire regions. As responsibilities continue growing, compensation grows as well. Entry-level high-voltage electricians may begin earning competitive salaries, but experienced specialists working on major industrial projects, utility systems, or large-scale commissioning operations can earn well into six figures, particularly when certifications, overtime, and travel assignments are included. Their expertise is highly valued because replacing years of technical knowledge, practical experience, and sound judgment is never easy. Yet most professionals will tell you that the greatest satisfaction comes from something far more meaningful than the paycheck. It comes from knowing that hospitals continue treating patients, factories continue producing essential goods, cities remain illuminated, and entire communities continue functioning because electrical systems were designed, maintained, and restored correctly. Every successful project represents countless hours of preparation, teamwork, and attention to detail that most people never notice, but everyone depends on every single day. From learning the fundamentals of electrical safety as an apprentice to leading the commissioning of some of the world's most advanced high-voltage installations, every level of a high-voltage electrician's career is built through discipline, precision, and continuous learning. It is one of the most technically demanding careers in the skilled trades, requiring equal parts engineering knowledge, practical experience, and personal responsibility. For those willing to master its challenges, it offers outstanding career opportunities, excellent earning potential, and the privilege of working behind the scenes to power the modern world. If you enjoyed discovering how high-voltage electricians build, maintain, and protect the electrical systems we all rely on, subscribe to Career Atlas for more documentaries exploring the world's most fascinating technical, industrial, and engineering careers.